All right, what are we going to do tonight?
Hold on, let me get out my homework.
Okay.
So, tonight I have, solving systems by elimination.
Okay. Give me your two equations.
2x plus y equals 4, and then x minus y equals 2.
The reason this technique is called elimination is because we're going to eliminate one of the variables. And we can do that by either adding or subtracting the two equations from one another. In this case, if we add the two equations, and you always can do, you can add equations and you can subtract equations. If I add these two equations, the y variable gets eliminated. So what do I have if I add them? Add this equation to this equation. Add the left sides and then add the right sides.
So it'd be 2x squared plus
3x. We're adding, not multiplying. In other words, if you add 2x plus 1x, you get 3x.
Okay.
The y's disappear because plus y added to minus y is 0. And then the numbers add to 6.
Yeah.
So now we know x is equal to 2. And now you go back in and you plug into either equation the value of x and you solve for y. So if you plug in x equal 2 into that equation, what is y equal to? In other words, I'm going to have 2 minus y equals 2. What does y have to be equal to?
2.
Well, 2 minus 2 would be equal to 0. So that's not right.
Not sure.
Okay, well, if we solve it just like an algebraic equation, let's move the y over to the right side. Let's move this 2 over to the left side by subtracting 2 from both sides, and we get y equals 0. So there's your solution. And we did it. There's lots of ways to solve simultaneous equations. And to me, the easiest way is this one, where you eliminate a variable.
Okay, hold on. Let me get that copy down.
Oh, excuse me. Sorry. You can always, I also remember, post this recording of this file on your web page. So you can always review this if you want.
Okay, the next one.
Yeah, let's do another one and see if you can do this one this time.
Is x minus y equals -5. Then x plus 2y equals 4.
notice that we can't add these equations and have one of the variables disappear.
Yeah.
However, we could subtract them. In other words, if we subtract equation number 2 from equation number 1, the x variable disappears. So let's do that just as an exercise in a different way to solve these. It's not really that different. We're just subtracting instead of adding. So if I subtract equation 2 from equation 1, how many x's do I have?
0.
How about y's? What is minus y minus 2y?
Just y.
No, we got minus y minus 2y. Okay, the easiest way to solve these, a lot of people have problems with these. For one thing, these dash marks don't mean the same thing. This means a negative, this means subtraction. So the way to solve a subtraction problem is to turn it into an addition problem. We do that by changing the sign of what was being subtracted. So now we have minus y plus a minus 2y. What is that? It's minus 3y.
Yeah.
In other words, we have a minus 1y plus a minus 2y, you get minus 3y. Okay. And now what about the numbers? What is minus 5 minus a plus 4 equal to?
Negative 1.
No, do this the way I just taught you. This is the subtraction here. So let's turn it into an addition problem. We do that by making that addition, but we can only do that if we change the sign of the whatever follows.
Negative 9.
Right. So now the 0x is what disappeared. And what is y equal to? Divide both sides by this coefficient.
Oh, yeah.
What's minus 9 divided by minus 3?
2.
9 divided by 3 is 3, and the minus divided by minus is a plus. Okay, so the first variable we solved for here was y. Yeah. So how do we solve for x? Because our goal is to solve for both. We don't want to just solve for one. We had one of the variables disappear, but that doesn't mean we can't solve for it. We can now go back and solve for it. Substitute that back into that equation. What do you get?
The equation is going to be x minus 3 equals negative 5.
Okay. Now solve that for x.
You add 3 to both sides.
What is minus 5 plus 3?
Negative 2.
And there's your two solutions. So it doesn't really matter which variable you eliminate. Now, before we go on, let's look at this again, because I'm not convinced that we chose the easiest method to solve it. For one thing, people have a lot harder time with subtraction than they do addition. So if you can solve simultaneous equations by addition, you're better off. There's less likelihood of making a mistake. Well, we can't do that. If we add these things, I get 2x plus y equals minus 1. But
Yeah.
remember with equations, you can do anything you want to the left side as long as you do it to the right. So what if we were to multiply the left side of this equation by 2 and multiply the right side of that equation by 2? What would we get? What's the left side become? Distribute that 2. 2x what?
Minus 2y.
And the right side?
Would be negative 10. No, yeah.
That's correct. Okay, so now this becomes our new equation 1. And now we're going to operate on these. Remember, I didn't change anything. I just multiplied both sides by 2. And now notice that we can add these two equations, which is far simpler than subtracting equations. So if I add these two equations, what do I get?
3x plus y.
No, the y's go away. The whole reason I multiplied that first equation by 2 was so that I would end up with a minus 2y. And I did that purposefully because I knew when I added the equations I would not have any y. So what is this equal to when you add those two?
It would be negative 6.
Okay, and now x is equal to minus 2. So this way I solve for x first, and now I can go back into either equation. Let's take the simplest one, this top one. Substitute minus 2 for x, so we have minus 2 minus y equals minus 5. Easiest thing for me to do is to move the y over and move the 5 over. So I'm going to end up with y over here. I'm going to add 5 to both sides, so that's my solution for y. So notice that, whoops, excuse me, that's positive 3. Did my algebra a little funky. So I get the same two solutions. And that's the key. Now, did I make the problem easier or harder? I don't know. I'm going to let you decide whether you'd rather add equations or subtract equations. You can't always do either, but sometimes you have to manipulate one of the equations first before you can add them and have a variable disappear. The key is to getting a variable to disappear.
Okay.
What else you got?
Next one is 4x plus 8y equals 4. And then negative 4x minus 8y equals negative 15.
What do you get if you add these two equations?
Gonna end up with x.
No. 4x plus a minus 4x is 0x.
Okay, 0x plus 0y equals negative 11.
Well, 0x plus 0y is just 0. Because anytime you multiply anything by 0, you get 0. So we get 0 equals minus 11. When you see a solution like that, that's an impossibility, and it means that there is no solution. There is no value of x and y that makes that true. In other words, these two equations are not consistent with one another, and they're not solvable. There is no solution. It is impossible to have both of these be true. So when you get an answer like that, that's what it means.
Okay.
Likewise, if I gave you this, this might look like it's two equations and two unknowns, but it really isn't. It's really one equation, and the only way I got the second equation was by multiplying the first one by 2. So this is not going to give me a solution either. There are an infinite number of solutions to this. Notice that if I were to multiply the top by minus 2, and then add, I get 0 equals 0. Meaning I have no way of solving this because there are an infinite number of solutions. In other words, if I just give you one equation and two variables like this, notice that x could be 1, y could be 4. X could be 2, y could be 3. X could be minus 1, and y could be 6. In other words, I can go on forever. There are an infinite number of solutions to one equation and two variables. It's a key thing to understand. If you have two equations and two variables, as long as they are independent of one another, by independent of one another I mean as long as one is not just a multiple of the other, then this will produce one unique solution for x and y. In this case, I would multiply top and bottom by 5. Now add the two equations, y will disappear. You get 7x equals 35, x equals 5. Now go back and solve for y. But in other words, as long as you have two independent equations and two variables, you will always solve it and get one exact solution. As long as they're not conflicting, like the last problem you gave me was, where we got 0 equals 11. That means you don't have a solution to that. What else you got?
2x minus 3y equals 0, and then 3x minus 2y equals 5.
Okay, notice what we got going on here. I can't multiply one equation by an integer such that a variable is going to disappear. I could multiply the top or the bottom equation by 1.5 plus or negative 1.5, and I could get y to disappear, but I'd rather not involve fractions if possible. Don't complicate things by involving fractions. So in this problem here, I want to do something to equation 1 and equation 2 such that when I then add them together, one variable will disappear. Well, what if I multiply the top equation by 2 and the bottom equation by minus 3? I chose those numbers because that is the common denominator. Notice that if I multiply the top by 2, I'm going to have minus 6y. And if I multiply the bottom by minus 3, I'm going to have plus 6y. So by manipulating both equations and then adding the results, I'm going to get a variable to disappear. So here's the new equation 1. Here's the new equation 2. Now, these two equations are easily solved by adding them.
Yeah.
What do you get when you add
them? Gonna get
What's
negative
4x?
5 and
The y
plus,
disappears.
yeah, y disappears, and then it's gonna be negative 15.
So what is x equal to?
3.
Okay. So now, which equation do we want to plug that back into to solve? And my answer is always the easiest one. Let's go back to this first equation. These two equations are about as easy, but let's go to it before we fiddled with it. And let's plug in our answer, x equal 3, to solve for y. So plug in x equal 3 here. What do we get? Just plug in x equal 3, so we get 2 times 3, so we get 6 minus 3y equals 0. Going to move the y to the other side. Get 6 equal 3y, and now y equals 2. So there's my solution. Y equal 2, x equal 3. And if you were to check those solutions, both of these would be true. Notice that if x equals 3, we get 6 minus 6 equals 0. And this one is 6 minus, or x is equal to 3. So this one becomes 9 minus 4 equals 5, which is also true. You don't always have to check your solutions, but it's good to know that when you do, they are correct.
Okay.
Okay, so every one we've done so far is a little different. We added one, we subtracted one, we had to multiply one equation by a number on another, and then the fourth one we did, we had to multiply both equations by a number. So you getting the hang of it? We're trying to manipulate these equations so that when we add them together, a variable disappears.
Yeah.
That's the name of the game. So what else you got?
Let me see. I have a family dinner I have to be to at 6, so I'm gonna have
That's
to
fine.
cut this
Yeah,
a
we
little bit.
can cut it off early here. You just let me know.
Alright. I mean, pretty much all the homework she gave us is the same stuff, and
Let's do one more. Let's do enough of them until you can do the whole thing.
Okay. Next one's 2x plus 6y equals 4. And then 3x minus 7y equals 6.
You're correct. These are all the same, but that doesn't mean you know how to do them yet. So let's make sure you know how to do them on your own. I'll try to keep my mouth shut. What's the first thing you want to do?
Add them together.
Well, what would you get if you added them together?
Get 5x minus y, equals 10.
Problem is we can't solve that.
Yeah.
In other words, when you're using elimination, you got to make sure that you eliminate one of the variables. So what do I have to do to this equations so that when I add them, a variable will disappear? What's one thing I could do? Pretty straightforward.
Subtract.
No, if I subtract them, I'm still going to have two variables. I've got to manipulate these equations so that, in other words, say I multiply the top by minus 3, I multiply the bottom by 2. What's going to happen to my x's?
One's going to be negative, one's going to be positive.
One's going to be negative 6x and the other's going to be positive 6x.
Yeah.
That means when I then add them together, my x's are going to disappear. So this will work, and this is what you have to look for, is little techniques where you can multiply both equations and end up with one of the variables having the same coefficient, opposite signs. So tell me what equation 1 should be if I multiply both sides by minus 3. We're doing this.
Yeah, okay, it'd be negative 6x plus negative...
Minus 3 times 6y is what?
Negative 18y equals negative 12.
Okay, and in the bottom equation, multiply every term by 2.
It'd be 6x minus 14y. And then equals 12.
Now add the two equations. It's minus 18y plus minus 14y.
It's gonna be 4. Oh, yeah, right.
We're adding a minus 18 plus a minus 14. Same sign, you just add the numbers and then you attach the sign that they both are.
Yeah.
And what do we get on the right side?
0.
So what is y equal to?
Negative 32.
No. I have to divide both sides by minus 32. Leaves y all alone on the left. The right side is still 0.
Yeah.
0 divided by negative 32 is 0. Okay, so I have one solution, y equals 0. And now notice that I always want to go back to one of the original equations just because they're simpler. In other words, these equations have bigger numbers in them now. So I could solve for x by substituting 0 for y here, but it's easier to solve for x by substituting 0 for y here. Let's erase what we multiplied it by. Substitute 0 for y and solve this equation.
Hold on, let me write it.
So the equation is 2x plus 6y equal 4. Substitute 0 for y, and read, what's the next line read?
2x plus 0y equals 4.
So 2x equals 4. Remember, 0 times anything is always 0. So if you have 0y or 0 times anything else, you got 0. So x equals 2. So our solution is x equals 2, y equals 0.
Okay.
Let's do one more until you can do it on your own.
Okay. Okay. It would be 2x minus y equals 6. And then negative x plus y equals -1.
Okay? Tell me what we're going to do here.
We're going to have to multiply the top by...
Well, no, not necessarily. The first thing you should do is see whether or not, if we add them, will a variable disappear? Second question is, if I subtract them, will a variable disappear? Well, what's the answer to the first question?
Oh, yeah. The y will disappear.
Okay, so let's add these two equations. What do you got?
Okay, so it would end up being x plus, or no, the y's go away, so it would be x equals 5.
And now, how to solve for y?
You have to plug in the x in the bottom equation.
Okay, so we'll plug it into there. What does that become?
Negative 5x plus y.
Negative 5. In other words, we're not including the x. X is equal to 5. We know the solution for x. So every place we see an x, we're going to substitute a 5. Now what's y equal to? It's -1 plus 5.
It'd be 4.
So there's your two solutions. Y equal 4, x equal 5. Now that was an easy one. I'm guessing that that was one of the first ones in your exercises, not one of the 5th or 6th ones.
Actually, that was problem 6.
Was it? Okay. The only reason I said that is because that did not require any manipulation whatsoever of the equation. In other words, that is the simplest case scenario right there, is where you can just add the two equations straight away and one of the variables disappears. Much harder was the other one where we had stuff like this. The only way to solve this by elimination is to multiply both equations by different numbers. So these are much harder. Okay, you want to do another one?
I actually got to get going.
Okay, that's fine. Andy, I will talk to you next Tuesday night at 5.
Yep. All right,
Okay.
sounds good. Thank you.
All right, bye-bye.
Bye.